So let's look at an example of calculating a derivative of vector valued functions. So for the vector valued function, r of t is going to be ti plus t squared plus 2j. Find r prime of t. Then you need to sketch the plane curve represented by r of t and the graphs of r of 1 and r prime of 1. So let's start with what we're first asked to find. We're first asked to find the derivative of this vector valued function. So what is r prime of t going to be? Well, remember, you just take the derivative in each component. The derivative of t is 1, so it'll just be I. The derivative of t squared plus 2, it's 2t. So here's my derivative. I was also asked to sketch the plane curve represented by r of t. So it might be easier for us to recognize what kind of curve this is if we switch to parametric equations. So if I look at r of t here, I have x and I have y. So I'll convert those into parametric equations. It'll be x equals t and y equals t squared plus 2. Well, since x equals t, if I take that and substitute into the second equation, I'm going to get y equals x squared plus 2. So I know that this is the equation of a parabola shifted up 2 units. So let's go ahead and sketch this plane curve here. Here's my 1, it's 3. So I've sketched the plane curve. Now they want me to, and just so we know there's a direction, right, to this. If you want to think in terms of parametric equations, there's a direction. It's increasing up as t increases, so it's going kind of along those lines there. And if I plug in 1 into my function r, you're going to get I plus 3j. So if you draw r from the origin, it's going to point to my point on the graph here. Here's my vector r of 1. Because this equation r represents this curve, I know that the terminal point of this vector was at the point 1, 3. And then if we plug in, go back to our derivative now, if we plug in 1 into the derivative, you're going to get I plus 2j. But for this derivative, instead of starting this vector at the origin, we're going to instead start the vector at the terminal point of our previous vector. So we're going to draw it so it's a tangent vector essentially. And so this vector would go out a distance of 1 in the x direction and up 2. So it's going to go like this. Here's my... So this is r prime of 1. So again, for the vector on the curve, I just graphed it starting at the origin, but for this derivative vector, I started on my curve at the terminal point of the previous vector.